So in the last video, I was showing you what I did in this pom.xml regarding widget dependencies I'm using in this application, and also other configurations that exist in this project. So basically, I copy paste this pom.xml when I complete these challenges on CodeCrafter. So I'm using basically one pom.xml and then adapt it if I need something else in another project. So, and yeah, so that's basically it for pom.xml. And in this video, I would like to show you what I do almost on all projects that I'm building. So you probably heard about using, so if we want to make our application really like so with solid principles, with regard to solid principles, so that our code is maintainable and really open to changes. If business requirements shift, we can adapt uh, those uh, those requirements, and without a real hassle of, for example, restructuring our application, refactoring it somehow. So we as developers and LLMs and agents, we should stick more with composition, design for composition, and implement using composition, delegation and interfaces, traits, all of that, type classes, and not really use inheritance, because inheritance in most situation it makes code brittle, rigid, and hard to change if requirements evolve. If you do not really believe in my words, so basically, yeah, so I had an experience in fixing bugs and extending some legacy applications in my job. So this is like day-to-day activities, and it is really hard to break those hierarchies of inheritance. Maybe in some cases it is not even impossible, because some of the parts of the classes are come from frameworks or libraries. So this is like complete hell. And yeah, so I have experience with super hard like maintenance of inheritance based application. And in new application I would, yeah, and basically we have a lot of videos regarding using composition over inheritance. You can go to, for example, I will actually attach the links in the description to this video, I mean in the comment section. For example, there is a YouTube channel called Aesthetic, which describes precisely what flows of inheritance are. You can also read the book from Joshua Bloch, Effective Java, where he says that we need to design for inheritance or else prohibit it. So I opt for prohibiting, because there are a lot of instruments that we can use for example, code reuse, and leave interfaces for subclassing. So yeah, I will attach this video and also some other videos. For example, this one from Stefan.
Hi, it's Steph Mishchuk. In this video,
Mishok, he has a huge a lot of experience, and he talks on his YouTube channel, and he also teaches other people. So he also describes what are flaws of inheritance, and we basically, yeah, so there are lots of materials. You can go online and search and read it from really experienced developers, what are the flaws of inheritance. And if you can see more and more languages coming, like what was developed after Java, after C#, after Kotlin, they do not introduce such feature as inheritance in their language. Basically, for example, Rust, it has a concept of traits. For example, in Scala, we can use type classes to extend to new functionality to existing types. Also, Golang, it does not have inheritance, because the and also Gleam also does not have inheritance. All of these languages, probably not Scala allows inheritance because of, yeah, but all new languages, I do not see that they include inheritance in their core language features. But instead there are structs and functions. Some languages prohibit even mutability, like Gleam. Others just live with those structs and functions attached, allow mutability. And for example, Rust, but yeah, it's talk about mutability. But here, yeah. So, but what to do if we implement our applications? Of course, I would like to say regarding Yegor Bugayenko, who also has a lot of experience, like 30 years of experience. He also promote that inheritance is bad for applications. So you can also watch him on YouTube. So there are a lot of authors. So basically there are, yeah, so I cannot like include all of these authors, but you can definitely search them on YouTube, on on Chrome. Yeah, but what to do if we are if we are using Java or Kotlin or C# in our applications? For example, for Kotlin, mm, we have opportunity to inherit classes in whichever manner we want. We just make a class open and just, or make it abstract, and then use inheritance, use design patterns based on inheritance and all of that shit. But if you're if you're team leader of, or tech lead, or some in the managerial position, you can enforce architecture by using tests. So, for example, in Kotlin, there is a library called cotest, which comes from this from Maven. I included. I mean, consist. Sorry, not cotest, but consist. So this library allows us to declare the test, or write the test to enforce architectural decisions. So we, of course, we can document for architectural decisions, but it is a bad thing to do, because each developer does need to always remember the documentation. So the proper way of enforcing architectural decisions is using tests, using languages capabilities, uh, static code analysis tools to prevent the problems in the very beginning of the SDLC, software development lifecycle. So many languages, like I already said, like Golang or Rust, they prohibit inheritance in the language level itself. So there is no ability to use inheritance like at all. But what to do in Kotlin? I use this consist library, as I said, and here you just need to implement basic tests that basically, so we have this consist, which comes from this class consist object, not class, but object consist comes from this library of consist. And what we do is that we scan all of so we take the scope of all our project. It means that it grabs all of the classes within our project. So it does not grab the external libraries classes that based on inheritance. No, it just grabs our files, our Kotlin classes, and we can do tests on them. So we grab all of the classes, and this classes function returns a list of class declarations. So this class also, called declaration, comes from also consist, as you can see. And next, what we do is we filter not is exempt from inheritance restriction. So this function as a property, this function just determines that here we can specify some of the exceptions exempt from inheritance. So it means that we can specify some of the things that actually allowed to use inheritance. For example, runtime exceptions. So Java and Kotlin developers tend to use runtime exceptions and create a subclasses from runtime exceptions and throw them. So this is also like we can speak about that, but I do not prohibit it in my projects because runtime exceptions are a really flexible thing to do, and the only way, like the good design, is to not use raw runtime exception, that is not throw runtime exception, but to throw the child of runtime exceptions. For example, here I have, or maybe so I have, for example, exit intercepted exception. Also, somewhere I throw it and catch it. Also, there is a thing as command line runner. So this is like command line runner comes from Spring Framework to define the component that needs to run on application startup. So this comes from Spring. So as you can see, there are some cases in which there is no way other than just use inheritance to integrate with other external libraries or frameworks or whichever code we have external. So this should come as exempt. So here this function or property is a function, or so this function, in this function you can define further as you develop, you can go and define more exempt from inheritance. But and what I tend to do if I go on a real project, I would like to make this consist test code owner as me. For example, the project lead or tech lead or team lead or someone in managerial position, so that only managers can make differences within this class and not regular developers. So this is like enforcement. So what developers can do if he really needs to use inheritance is that he, for example, wrote for inheritance, he run this test, and then he sees if this test fails, then if it is really the case of proper use of inheritance, it goes to manager and it submits and makes the commit to allow for usage of inheritance. And if not, then we can, this manager can help the developer. For example, project lead or tech lead can help developer to force him to use composition, delegation interfaces or traits. So that's basically it. But the overall idea of this test is to force developers to use more composition and not inheritance. And as a consequence, you can read from books, you can see from videos. It enables the code, it makes our code more flexible and ready to incorporate more changes or swap the implementation if business, for example, decides to drop entirely functionality and rewrite everything or most of the application, not most of it, but some feature that, for example, already developed and has, for example, 300 lines of code, but you need to change the structure. If you implement this feature using inheritance, then your code becomes rigid and hard to change. This is something that I faced and other developers face. So So that's basically it. And yeah, so thanks for watching. Bye.